안녕하세요. 자, 이번 시간에는 우리 챕터 5에 나오는 바나하 픽스드 포인트 디어럼에 대해서 이제 간략하게 이제 공부를 하고요. 이 챕터 5는 이제 요것만 하고 이제 나머지는 이제 그냥 넘어가겠습니다. So what we are going to study today is Banach fixed point theorem, and this fixed point theorem is very important in studying nonlinear equations. In particular, in order to prove existence of solutions, so we used fixed point theorem a lot. And so let me introduce a definition first. So consider T is a map from x to x. So in x to x, and the element x in x is a fixed point of t, means that tx equals x. So t maps x to itself. Okay, so this is the fixed point theorem. And then one of the definition for fixed point theorem, we use contraction map. So let xd be a metric space, and T is a map from x to x itself, and T is called a contraction on x. Means you have two distance between metric between tx and ty, and we compute tx and y, and they are. And this one is less than alpha times dxy. So this map is this one. So let me explain this one. This is x and this is x. This is a map t. You take 2 points is x and 1 point is y, and you got the tx here, ty here, and the distance between these two and distance between two, which is smaller. This one is smaller than this. So t maps smaller distance between x and y map into tx and ty. Is this distance is smaller than the original ones. So this is construction map. And the Banach fixed point theorem is the following. This construction, this is not, this is a kind of typo, contraction. I don't know why I put the construction theorem. Contraction theorem. And suppose x and d be a metric space as a non-empty set. And suppose x is complete metric space, and T is a map to x itself in contraction map, then T has a fixed point. So contraction map from complete metric space to itself has a fixed point. So this is the fixed point is unique. So which means it has unique solutions somehow, right? Okay. So in order to prove this one, x is a non-empty set, so you choose one element here. X is one element, and then I can define a sequence xn, and we composite t how many times? N times. So you t to the nx. So this is our definition. Then we want to show this sequence xn is a Cauchy sequence. So how do I prove this one? We use a contraction map. So this T is a contraction map. We apply the contraction map. The T, this is contraction. And then we look at the Txn plus 1 and xn. The distance between xn plus 1 and xn. And by definition, this is a Txn, this is Txn minus 1. And T is a construction map. This is less than or equals to alpha times d xn x minus 1. Okay. Again, the definition, this guy is a txn minus 1. This guy is a txn minus 2. And also this maps contraction, you have alpha squared d, this one. So using this is a t xn minus 2, this is t xn minus 3, and then you apply this one contraction map again, you end up with getting alpha to the n dx1 and dx1 and x0. So which means so for every n, the distance between xn plus 1 and xn is less than or equals to alpha to the n x1 and x distance. You remember this one? And using this, you got for every m and n, suppose m is greater than n, and dxn, okay, distance between xn and xn, and then using a triangle inequality, you add this part, and then triangle inequality, you got this one, and and then you apply this theorem, this property, this alpha to the n minus 1. This follows index here, this index. So this index alpha to the n minus 1, d x1 and x. And then here, this is it, alpha to the n minus 2, and so on. And then you take this one, a common factor, you take outside. So you get alpha n plus 1, alpha to the m. So we have this one. And then you can compute the sum of this is 1 minus alpha, this is the first term, alpha to the n, 1 minus to the number of how many terms you have. The number of terms is m minus n. Okay, this is obviously less than 1 over alpha and alpha to the n dxn, dx1 and x0. So for every m and n, dxn comma xn is less than this one. Okay, so if the distance between x1 and x0 equals non-zero case, if non-zero, then you can choose for every epsilon, and you can choose 1 minus alpha to the n is less than epsilon. Okay, because alpha is between 0 and 1. So you take a large number n, this becomes very small. So you can always choose a natural number satisfying these conditions. So you solve this one for alpha n is less than this guy. Okay. Then for every m and n is greater than capital N dxn, this whole thing is less than epsilon, right? Okay. So this guy is n. So n is greater than capital N, then this would be, you know, this guy. Go for this, and then 1 minus alpha to the n d x1 and x0. So if n is greater than capital N, okay. So then this is less than epsilon. Here, this is less than epsilon, and then we have proved for every epsilon. So here, for every epsilon, there exists m such that this one holds, which means the sequence xn is Cauchy sequence. Okay, xn is Cauchy sequence. So we proved Cauchy sequence. On case 2, so if this guy is 0, this guy is 0, then dx0 x equals 0, then tx0 x0. So x0 is actually a fixed point. So we are done. We don't need to do more. For second case, we proved the theorem. First case, this is non-zero, then xn is Cauchy sequence. Then x is complete, so the Cauchy sequence converges to x. Okay, Now we want to prove this x is the fixed point. So how do I prove this one? Well, let's see. So we compute the dx and tx. So we need to compute this one. And then we add xn, subtract. So using triangle inequality for every m. And this guy is the same as txm minus 1 by definition. Okay, by our construction. And then we use this is construction map alpha times d xm minus 1x. Okay, so we have this property. So now, so for every epsilon, given epsilon, and then we can also choose dxn, distance between this is 1 over 2 alpha epsilon, because xn converges to x. So you know this one, and you can choose capital N, satisfy these conditions. Okay, so we apply this one, and finally we have tx, and I take m 2n, this is 2m minus 1, so I take d x2n alpha times x2n minus 1 here. So for every n is greater than capital N, this is less than this guy. So 2n minus 1 is obviously greater than n, right? So both of them is 1 over 2 epsilon over 2 alpha. So alpha times epsilon over 2 alpha. Okay, so then alpha is between 0 and 1, 0, 1. 1 over alpha is greater than 1, right? Greater than 1. So 1 over alpha is greater than 1. So 1 over alpha is greater than 1. Okay. Less than 1. Okay, let me look at this one. So x2n. Well, so let's see. We fixed this guy. Let me fix this one. D xn x is less than minimum of epsilon over 2 1 over 2 alpha epsilon. Okay, so we use this one. So this guy is less than this one, so we remove this part. Okay, so we remove this part. We replace that one by this one. Okay. Then for every n is greater than large capital N, and this is satisfied, then this guy is less than epsilon over 2. This guy is alpha times epsilon over 2 alpha because of this one minimum. So finally we have epsilon over 2 becomes epsilon. So in this note, please fix your note, remove this part, and you put this guy over here. Then we can handle the rest of the time, rest of the proof. So then for every epsilon, we have d x and distance between x and tx is epsilon. So this implies distance between these two are 0. So that means tx equals x. So this implies x is a fixed point. Okay. 자, 여기에서 이제 우리가 이제 construction maybe fixed point를 어떻게 증명을 했냐면 x가 난제로니까 난제로 엘리먼트니까 여기 원소 하나를 끄집어내서 얘를 가지고 n을 가지고 n번 합성을 하면은 xn이라는 수열을 찾아냅니다. 그 수열이 이제 코시 수열인 걸 증명을 하면은 그 코시 수열이 수렴하게 되거든요. 그 수렴하는 것이 바로 fixed point 된다라는 것을 이제 방금 증명한 내용입니다. xn이 수렴을 하게 되면은 그 수렴하는 요 x 극한이 이제 t의 맵에 대한 fixed point 된다는 거고요. Okay, now we're going to put uniqueness of the fixed point. So suppose we have another fixed point x tilde. Then in order to prove x and x tilde are the same, we also compute distance between x and x tilde. And because x is fixed point, so x is the same as tx, x tilde is the same as tx tilde, and the t is a construction map alpha times dx, dx x tilde, right? And if this guy is less non-zero case, if the distance between x and x tilde non-zero, so this is less than 1, and this is less than dx x tilde, and this guy's contradiction, right? So if this one is non-zero, then this holds, we have contradiction. So finally we can conclude x tilde distance becomes 0. So which means x equals x tilde. Okay, by definition of a metric. So this is a uniqueness of theorem. Okay, next corollary is we have error estimate here. So this one is very important in numerical analysis. Okay, you compute error estimate, and also in numerical method. So we have a numerical ODE and numerical scheme. In many cases, you have to prove existence theorem, right? So in that case, we used iteration method, which is actually the fixed point theorem. Okay, so x equals xn equals t. Let's see. This one I have to use the fixed here. So xn equals t n x0. Okay, x0. Then you estimate xn distance between x and xn. So this limit, right? That is less than alpha m over 1 over alpha d x0 x1. We already proved this one in the previous slide lecture. And then this is called the priori estimate. Okay, so this is called priori estimate. And then dxn x is less than alpha over this guy. Okay, this guy is called the posteriori estimate. In numerical analysis, you will see prior estimate, the posterior estimate. Okay, the reason why we are doing this, so we don't know exact solution x fixed point. Okay, but we approximate x by xm. So we don't know exact value, but we know the approximated value, and we want to know what would be the error estimate. So this is very important. Okay, that's why, you know, in numerical analysis you need the approximate solution, right? We cannot find the numerically exact solutions. Well, if you're lucky, then you can find it, but it's very difficult to find the exact solution. So we had approximated solution. So this exact solution, this approximated solution, and we need to estimate between these two solutions. That is called a priori estimate, posteriori estimate. Okay, then the proof of this one is very not difficult. So I'm going to skip this one. And then next also theorem, we have one more theorem here. Contraction on a ball. So let's look at what the statement is. T is a mapping from complete metric space to itself. So Okay, if T is a contraction map on the ball, closed ball, and such that dx and tx is less than this guy, then by iteration method, xn equal t and x is converged to x to y. Okay. So this is probably the proof is similar to the previous one. So this is not difficult to prove. So I want you to look at our note. Okay, this is the end of chapter 5, and rest of it in chapter 5 you can read by yourself, and also whenever you need, when you do research, you can look at the textbook. Okay, so let me stop here. Thank you very much. 자, 오늘은 여기까지 합시다.